Hello everyone, welcome back to the lecture series on Foundations of Deep Learning, Concepts and Applications. In our previous lecture, we have discussed about LSTM with attention mechanism. In today's lecture, I will introduce you with a completely new topic, which is natural language processing. So the contents for today's lecture session goes like Introduction to Natural Language Processing, which we call as NLP. Then we will speak about the NLP tasks like sentiment analysis, machine translation, text classification, text summarization, question answering, text entailment, named entity recognition, chatbots, and language modeling. So, we will start with an introduction to what is natural language processing. Natural language processing is a technology that allows computers to interpret, manipulate, and comprehend human language. That means it is the process or technology by which human language is being understood by a machine and then specific tasks are done by that understanding. NLP is used by many applications such as text translation, text summarization, speech to text conversion, chatbots, and etc. There are so many more applications we will see. So, all these applications require natural language processing, which means the machine will understand how humans speak, and then based on that understanding, they will apply the concepts and they will apply the entire technology for applications like text summarization, text to speech conversion, speech to text conversion, chatbots, etc. Conventional NLP refers to the rule-based and statistical approaches to processing human language. So, conventional NLP are all statistical approach-based and rule-based techniques, whereas deep learning-based NLP refers to approaches that use neural networks, particularly deep architectures like recurrent neural network, convolutional neural network, and transformer models to process and understand human language. Then we will come into the NLP tasks. So, what are these tasks? These are basically the applications where NLP is used. Okay. So, we will start with sentiment analysis. What do I mean by sentiment analysis? We will have some examples and we will understand what sentiment analysis does. Suppose okay, so before going into the in-depth of sentiment analysis, we will just have a quick look into all the NLP tasks that can be done using NLP technology. Sentiment analysis, text classification, machine translation, text summarization, question answering, text entailment, chatbots, named entity recognition, and language modeling. So, these are some of the most used NLP tasks, and we will see each of them now in detail. So, we will start with sentiment analysis. What exactly it means? Sentiment analysis means, suppose I have a sentence. I want to know whether that sentence is bringing some positive sentiment, negative sentiment, or it's a neutral one, neither positive nor negative. Okay. So, suppose I have a sentence and I have the associated sentiment. The sentence is, I absolutely love this phone. So, it's a positive sentiment. You are telling something good about the phone. This restaurant is terrible. So, it's a negative sentiment, something which is not good. The movie was okay, nothing special. So, we are neither saying it is a good movie, nor we are saying it's a bad movie. We are telling it's an okay movie. Okay, so it's a neutral sentiment. I never tasted a pizza like this. What is the sentiment of this one? So, there is an vagueness, ambiguity, whether the sentence wants to convey the message that they have never tasted such a good pizza, or they have never tasted such a bad tasting pizza. So, there is an ambiguity in the sentence, and sentiment analysis, it is difficult to capture the sentiment from this sentence. Then we will look into text classification task, in which NLP is very much required. So, text, we have a text and then we have a task, specific task for the text. Like here, we will classify the text as a spam or as not a spam, and then we will label it. Okay. So, we will have a look into examples. Win a free iPhone now, click here. So, if I give this text to the task, text classification task, it will give me the label, it is a spam. Okay. Similarly, your order has been shipped. So, if this is the text that is given for the text classification task like spam or not spam, it will tell it is not a spam. Okay. The stock market closed higher today after. Okay. The stock market closed higher today after something happened. Okay. So, if I give this text for the task classification or topic classification, it will tell it is falling under the category of business or finance. Cristiano Ronaldo scores a hat trick. So, if I give this text for topic classification, it will show it is under sports category. So, there are various ways we can classify a text, and it is very important that we can classify text under all these categories, because if we want to do some downstream task only by taking some text which are related to sports, then this classification is required, because after this classification only the sports related news or sports related text will come for the next part of the work. Okay. Then we come to something called as the machine translation. So, machine translation, it is related to language translation. Okay. So, you have an English sentence and you want to change it to some other language like German, French, any other language, Hindi, anything. Okay. So, you have a text like I like mangoes, and I want to change this English text to German. So, when I am translating this sentence I like mangoes to German, so I becomes ich like mangoes is mangoes. Okay. So, here what happens is the sequence of words in the input and output sentence are same. So, I is having one exact pair matching, ich like comes after I and mangoes come after your like. The same sequence is maintained in your translated sentence. So, ich mag mangoes means I like mangoes. So, there is a sequence matching between the input and the output sentence. Okay. Now, we will have a look into another sentence where there is a sequence mismatch, means the second word may go to the third word in the second word in the input sentence may go to the third word in the output sentence. So, we will have a look. I don't like mangoes. So, this is the English text and I want to change it to German. So, I becomes ich. Now, this don't becomes cane, and then like becomes mag, and mangoes becomes mangoes. Okay. Now, what happens here if we see that there is in the English sentence I don't like mangoes. So, that I is ich, that is fine. Don't or no goes, the term in German is kein. So, this comes second. So, I don't. So, this second word in the sentence is mapping to the third word in the output sentence, whereas the third word in the input sentence is mapping to the second word in the output sentence. So, there is a sequence mismatch, that is sequence of words in the input and output sentences are different. So, we will later see in my subsequent lectures, we will see how these kind of tasks or how these kind of cases are dealt with in NLP. Okay, we will have a look. Right now, we are just looking into the tasks, what they mean and what is the expected output. Then we will look into text summarization. This is a very simple one. From the name itself, we can make out that the task will be to summarize a portion of the text. So, suppose the original text is NASA's James Webb Space Telescope captured detailed images of distant exoplanets' atmosphere, revealing evidence of water vapor, clouds, and possible signs of life-supporting conditions. Scientists say this is a major breakthrough in the search for habitable worlds. So, this is the original text. Now, if I ask the machine to give me the summarized form, so the summary becomes like NASA's James Webb Telescope found water vapor and cloud on a distant exoplanet, a big step in the search of habitable worlds. Okay, so this is also a task or an application of NLP, and where we give not, this is a small text I have given, but it can be like few pages document, and text summarization will give me a summary, a very brief summary of what exactly is the information that is present inside that original text. Then we come to question answering. Suppose we ask the model or the machine who was the first woman to win a Nobel Prize. Okay, so I expect my model or the algorithm to give me the answer Marie Curie. Okay, so what is the process here? The model takes the context, okay, takes the question, it reads the question, who was the first woman to win a Nobel Prize. We will look into how this reading happens in the machine. We will look in my next session itself. Okay, the model, right now we will just take it that the model reads the question. Okay, once the model reads the question and understands the question, the model answers the question. So, this is a very simple simplified process flow. Okay, the model will take the context, read the question, and based on the meaning that the question is giving, the model will answer the question. Okay, now there is something called single hop problem and multi hop problem in case of question answering. What is this single hop problem? So, if you see, the first thing that I told here, the model takes the context. That means there is some paragraph or some document that is given to the model. The model reads that one and then it reads the question. Okay. Now, in single hop problem, what happens is the model has to read one paragraph or one single document to get the answer. That means it's a very simple question. Suppose you have given a one-page document and the model reads the first paragraph. There itself it gets a very straightforward answer for the question that has been asked. Now, that is called as a single hop problem. Okay. Now, what is the other one, which is the multi hop problem? In multi hop problem, the model has to read multiple paragraphs or multiple documents, link them by some logical reasoning to get the answer. So, there are possibilities or there are high chances in real world the questions that are asked may not be very direct. So, if the context is given to the model in the form of 2-3 documents, it is possible that the model needs to go through all the documents, get some information from document 1, some information from document 2, some information from document 3, and then they link them by some logical reasoning and find out the answer. Okay. So, this is called as the multi-hop problem. That means in one single hop you are not able to find out the answer. It has to go into multiple documents, multiple paragraphs, okay, of the same document or different documents, and then take out relevant information from all those parts and give the answer. So, these are basically little complicated questions to be answered. Then we go to something called as the text entailment. Now, what is this text entailment? 2 sentences will be given. The model have to tell if these sentences contradict, entail, or they are neutral. So, we will have a look into what are these text entailment means. Suppose I have an example. A black race car starts at the front of the crowd. Okay. A black race car starts at the front of a lonely road. So, you see in the first sentence it is the black race car starts at the front of the crowd, whereas in the second sentence, race car starts at the front of the lonely road. So, these are two sentences which are contradictory. So, here the text entailment is, it is not entailing, it is contradicting. Okay. A man is riding a bicycle in the park. Okay. This is my sentence. A person is like cycling outdoors. So, if we take these two sentences, bicycling, a man is riding a bicycle in the park and cycling outdoor, both are having similar meaning, because the park is a place which we can label as outdoor. So, this means these two texts are in entailment. So, they entail. And then we have another sentence. He is playing cricket with the kids. The kids are enjoying ice cream. So, there is no relationship between these two sentences. Playing cricket, the kids are playing cricket and the kids are enjoying ice cream. So, it is neither contradictory, neither it is entailing. So, this is a neutral case. So, this way, this gives the semantic in the context. If the meanings are very similar, then we get the entailment. Otherwise, if they are completely opposite, we get contradictory contradiction in the text, and if there is no relation, then we call it as neutral. Then we will look at another application of NLP, which is chatbots. Chatbots heavily depend on NLP because there an user gives his or her questions to the chatbot. The chatbot understands the entire text, understands what the user wants, and then based on its understanding, it gives a reply. So, in regular day-to-day use, we come across various chatbots. So, here also we will just have a look into the chatbots that requires NLP and how the question and answers are happening in the chatbot. We'll just have a look into that one. Suppose we have a customer support chatbot. So, we have a user and we have a chatbot. Hi, I ordered a phone last week. Can you check its delivery status? So, this is asked by the user to the chatbot. The chatbot is answering, sure. Could you provide your order ID, please? That means it has understood what the user is telling, and based on the user's query, it has given the answer. The user sees that answer from the chatbot and it is giving its 54732. This is my order ID. Thanks, that this is the chatbot's answer. Let me check. Your phone was shipped yesterday and is expected to arrive on Friday. Okay. Great. Can I change the delivery address? So, this is like a conversation that is happening between the user and the chatbot, and NLP is helping the chatbot to understand each and every sentence, the meaning of each and every sentence, and to generate the answer for that question. Okay. So, when the user tells, great, can I change the delivery address? The chatbot's answer is, yes, you can. Please click this link to update your address before 6 p.m. today. Okay. So, this is the way a customer support chatbot have an interactive session with the user. Okay. So, user, whatever their queries are, they will put to the chatbot and the chatbot will answer. But for this answering, what are the steps that are required? How the chatbot understands what is the question, what is the semantic that is present, semantic information that is present inside the the sentence that is given by the user. All these things we will have a look in my next session, how these things are happening. Okay. Then we have something called as the named entity recognition. What is named entity recognition? We call it as NER. NER detects real world objects mentioned in text and labels them with their entity type. Okay. So, suppose I have the sentence, Shourab Ganguly served as the captain of Indian cricket team, and he is from Kolkata. So this is the sentence. Now, if I want the named entity recognition, the NLP task named entity recognition to give me some output, it gives me Shourab Ganguly as a person, then Indian cricket team as an organization, Kolkata as a location, and yeah, so these are the entity that it is finding in the sentence. So one person, one organization, and a location. Okay. Now similarly, other than person, organization, and location, it can also show the time, the specific time, the date. So if there is a date, it will label it as date. If there is some money value, it will label it as money, percent, facility, events. So these all comes under entity recognition. Okay. So, named entity recognition is a process by which inside the text we see what are the entities that are present. Whether it's a person, we are speaking about a person, we are speaking about an event, we are speaking about some building. So, all these things we get clarity when we do this in named entity recognition. Then we come to something called as the language modeling. A language model is a natural language processing technique in which statistical or machine learning model is used to predict the next word in a sequence given the previous word. So, language modeling is all about predicting the next word in a sequence. Okay. So, it's a technique which uses statistical or machine learning models, and using those statistics of the previously used words, it predicts the next word. Okay. So, it sees what are the words that are present in the previous sequence. Means in a sentence, if I have 5 words and if I want to predict the 6th word, it will see what are those 5 words which are already there in the sentence, and based on that one, it will predict the next word. Okay. So, this is the main task of language modeling. So, suppose I have an input and I am predicting the next word. So, let us see some examples. I am going to the. So, this is the input sentence. What can be the predicted next word? It can be a store, a park, a market, anything. I am going to the store, I am going to the park, I am going to the market. Okay. So, these are all probable words that can come as a next predicted word or predicted next word. Then sun rises in the predicted next word should be east. Artificial intelligence is transforming I want to predict the next word. What can be the prediction? Not only word, it can give me a full sentence also. Artificial intelligence is transforming the world by automating tasks and improving efficiency. Okay, so this is basically a sentence completion task. Sentence completion task also comes from next word prediction. So it predicts the next word, and then that entire sequence becomes your previous history, and then it predicts the next word, and word by word this text generation will happen. And when we go into how these language models work, what is the working principle of these language models, we will get to know how this generation of text is happening, each word at a time, or how exactly the entire previous sentences or previous sequences information is gathered, and then the next word is getting generated. Okay. So, in my previous lecture, we have spoken about the LSTMs with attention, where we have used these kind of NLP text for showing how the generation happens for the next words. So, that is the way where the next word prediction happens. Okay. Once upon a time in a magical forest. So, this is a prompt. Now, I want the model to give me or complete the sentence. So, the generated text can be once upon a time in a magical forest there lived a tiny dragon who loved to paint rainbows in the sky. So, it is like a fantasy story. Okay. So, these are the type of work which we want the language model to do, and this is the type of work which the language models do. Okay, and it is basically, any language modeling is about predicting the next word. Okay, so that is about language modeling. Now we will see what are the challenges in NLP, what are the things that becomes very difficult when we are trying to use machines to understand human language and do some tasks. So, what are the challenges? We will have a look. Discrete nature of text data. What do you mean by that? Suppose sky and stars, red and pink. Okay. So, sky and stars, basically these are the words which have some similarity because the stars are present in the sky. Pink is a version of red. Pink is a color which comes from red. Okay, pink, red and white mixed together gives pink. But if we see, there is a relationship between sky and stars, red and pink, but words doesn't tell anything about the similarity. So they are discrete in nature. So if you take text data as a sky, star, red, pink, these are all discrete words. Okay, even though sky and star, there is a relationship, but if you see only sky, star, red, pink, you don't see any similarity, or there is no notion of similarity between these words. So that discrete nature of text data, it becomes a challenge when there is a relationship between two words, but it is not getting captured, and that relationship is very important for some other task, NLP task, like sentiment analysis, like text summarization, can be chatbot, can be anything. Okay, can be language modeling, etc. So that is one of the challenges in NLP. Second is evolving nature of natural language. What exactly it means? New words gets added to the dictionary. Like this word quarantine. This quarantine word got added very recently to the dictionary. It was not there from long time. So quarantine came when this kind of worldwide some pandemic happens, then this quarantine word came into picture. So these new words, addition of the new words to the dictionary, it this is evolving nature of the natural language, human language. It makes it difficult because the model once trained, it will not understand what is the meaning of quarantine. Then again you have to train that one. So this is one more challenge where evolving nature of natural languages, for that one the model needs to know, right, what are the words that are present in your dictionary. So that is one of the major challenges. Ambiguity or vagueness. Never tasted a pizza like this before. Now, when we get a sentence like this, never tasted a pizza like this before, it can be a good sentiment, it can be a bad, it can be a positive sentiment, it can be a negative sentiment, correct? Because never tasted a pizza like this before, it can be an excellent pizza, or it can be something which is not at all tasteful. Okay, so there is an ambiguity. From this sentence, I cannot tell anything about whether the pizza is good or bad, whether the sentiment is positive or negative. Okay, so there is an ambiguity, there is a vagueness in this sentence. Okay. Capture long range dependency. This is always a problem if there is a sentence, very long sentence, like here itself we can have a look. Animal did not cross the road as it was wide or tired. So both are possible. It depends on, see, animal did not cross the road as it was wide. It means the road was wide. Animal did not cross the road as it was tired. That means this word is related to the animal, and this road, this wide, when we are using this wide, it is related to the word road. So this type of long range dependency, capturing that one sometimes becomes difficult when the paragraph or the document is very long and there are long range dependencies from one part of the paragraph to the other. So these are basically some of the challenges in NLP, and We will see in my next subsequent lectures how these challenges can be mitigated and how NLP tasks are executed. So, with this one, I come to the end of today's discussion. So, I will summarize before concluding my session. So, we have started with what exactly is natural language processing. So, basically, it is the way a machine understands human language, and or in natural language processing, everything will be, the input will be text, sentences, in form of sentences, in form of documents, in form of paragraphs, okay. And there are various techniques by which natural language processing helps the machine to understand human language and then do some tasks. We call them as NLP tasks. And under that NLP tasks, it can be various categories of NLP tasks are there. Some of them which are very much used are sentiment analysis, machine translation, then text summarization, then language modeling, chatbots, and named entity recognition, text entailment. All these are various applications of NLP. We call them as NLP tasks. And we have seen each of them, what exactly when we tell that do a sentiment analysis for this sentence, what exactly it means. So, if it is a positive, if the sentence is giving any positive information, we call it as positive sentiment. Otherwise, if it is giving some negative information or telling something bad about something, either it is food, place, anything, okay, then we call it as negative sentiment. Otherwise, if it is neither positive nor negative, we call it as neutral. Then we have seen in machine translation what happens. Machine translation always deal with the language, conversion from one language to the other, translation from one language to the other. And there we have seen there are specific cases where your input and output sentences are exactly having the sequence to sequence matching, whereas we have seen some examples where the sequences are getting disturbed. So, we will look into later how these things are handled. Then we have spoken about named entity recognition. Named entity recognitions are basically about telling what are the entities that are present in the sentence. It can be a person, it can be an organization, it can be date, time, money, event, it can be location. So, all these things, these are the entities that are present in the text. So, text and named entity recognition does that work. Then we have seen text summarization, which is very simple, that you have an original text. That text can be very big, and NLP does a short summary of that one. Okay, so it gives a summarized form of the text that is present in the information or the context that is given to the model. Then we have seen how chatbots, what is the role of chatbot. It takes it goes in an interactive discussion with the user, tries to understand what the user wants to know, and based on the context that it is having or the information that it is having, it will keep on answering. So, it's an interactive discussion between the user and the chatbot. Then we have seen language models. In language models, we have seen the main idea of a language model is to predict the next word. And the prediction of the next word means it is required, the model needs to understand what is coming before. Okay, so whatever sequence we have given as input, it reads that one and then it predicts the next word or next few sentences or next one sentence. Okay, so this is about language modeling. And then we have seen what are the challenges that are faced in NLP. So, they are discrete in nature, evolving nature of natural language. New words keep on getting added to the dictionary, which our model may not be knowing. And then there is this discrete nature of the text, means there may be words which are similar to each other, but when we take them as separate words, there is no notion of similarity between these words. So, this is a discrete nature of language, text. Okay, so these are some of the challenges. Also, long dependency, capturing long-term dependency in a sentence sometimes becomes challenging because it depends on what is the context that is there, far away from the output that we are trying to see. So these are few of the challenges, and we will see in our subsequent lectures how do we mitigate them. And with this one, I conclude today's session. I hope you got the basic understanding of what exactly is NLP and what are the tasks that we can perform with NLP. In my next session, we will be talking about the text pre-processing that is required for the model to understand what is the meaning of the input sentence, based on which it will give some output. So text pre-processing and text representations will be the topic of my next lecture. Till that time, please keep learning. Thank you all.